Good morning, good afternoon, good evening, everybody. It's a pleasure to be able to talk to you today. My job this morning is to use our MChem chemistry programs. Without further ado, I'll move on to that. So first point is looking at why study chemistry. As I'm sure many of you can appreciate, chemistry's a sort of core science. It gets involved in all of the core societal challenges that we have, that our school focuses on, all the way from developing energy to protecting the environment, understand the environment, to human health and developing medicines, which of course at the moment's very, very important, all the way through to testing of foods and products that come onto the shelves in our shops and services. And also chemists have a role within society itself of communicating and acting as an interface between the molecular world and the sort of human scale world. So there's lots of opportunity out there for students to develop skills that can be useful to society, and that's very much our focus here in Plymouth. We offer a hands-on training in analytical focused chemistry, and many of my colleagues have sort of emphasised that already. At Plymouth, we really do have the opportunity for students to go into environments, and in our case laboratories, and refine their skills, not just have a quick go at something and say that they know how to do things, but actually practice their chemistry. I've got a lab tour on here which I won't play now, but I presume these talks will be made available to you so you can have a look at that. But here's two of our students, Chloe and Jayan, working away there in the lab on their chemistry. So chemistry is easy in terms of sort of talking about employability. Our graduates get very good opportunities and go into work very quickly. So typically chemistry courses will have around 9 out of 10 students in work within 6 months, certainly in the UK. But also note that in our breakdown, we also have 1 in 5 of our students going on and taking their chemistry further, going into further study, masters programs, postgraduate programs. So it shows that they really carry their chemistry forward and are sort of excited by the time they finish the programs and go on further. So what is analytical chemistry? I mentioned that that's a particular focus here in Plymouth. Well, analytical chemistry is one of the 4 branches of chemistry. We've got organic, inorganic, and physical chemistry as well, but it's the most practical chemistry, and that's one of the focuses we have here. The reason analytical chemists are so vital and so employable is that they, without analytical instruments, we can't actually see molecules and atoms, as I'm sure you can appreciate. They are too tiny for us to see. So in order to observe chemistry and observe what's going on at the molecular scale, we need to be able to use instruments, and that's a focus that we have. So at Plymouth, in order to ensure our students have that really good employability and really good skills that industry and research want, that is our focus, to make sure our graduates have that. So what's the point in that? Well, around 50%, according to a quote here, around 50% of chemists who graduate and go into their careers will end up being required to do analytical chemistry. So they can't shy away from it. And employers really value that skill because of that, because you have to be able to make measurements and see the chemistry that's going on in the industry and research. This is just a breakdown of how our jobs sort of fall out from the Royal Society of Chemistry. And the main sort of take-home message is that there's a kind of niche market out there for graduates. This is more the UK focused, but I'm sure it's the case in many other countries, around a quarter of the jobs are actually specifically for analytical chemists. So it really is lining people up for some success in their careers. On our course, we have a sort of what we call the 5 pillars. We have our laboratory skills, our knowledge and understanding. We have a focus on communication, people being able to get their science across, and that's a particularly important thing in chemistry, where a lot of the time we speak in what people would see as sort of hieroglyphics, to be able to get our points across to other people in the public or in industry. And in the middle there, we've got this problem-solving ability, which kind of links up all of our teaching. And then finally, project management as well. We have as in our final year projects, as many of my colleagues have said, our students get to do a research project which they manage. So that's a really sort of saleable product as well. To ensure this, we have to make sure our students are in the labs doing things, and we have to make sure that we have a wide range of modern instrumentation, which are the types of instruments that will be used in industry and in research. And we have that in Plymouth. We have that really great instrument base, which our graduates get to work on. And we see it like a sort of a gradient from starting off at undergraduate, sort of first year undergraduate, all the way through to becoming independent scientists that can use instruments and their skills to find things out and problem solve. And that's the exciting thing about science, is the kind of problem solving and the creative side. So yeah, we have to make sure that happens, and that happens in our course from the second year. Really, our students start working on instruments independently, and we just keep nurturing that throughout the program. So I guess a question I'd be asking if I was a student thinking about coming to the UK, is it a friendly and supportive environment, and will I learn chemistry with world-class teaching? And I think my colleagues have done a really good job of talking about how supportive Plymouth is. I mean, in our course in chemistry, we pride ourselves on having these sort of small group teaching. You can see a class here in the top right-hand corner of this figure. And we also try and get our students together to talk about their chemistry, and part of the engagement for a course is all about the students themselves having discussions as well. And this is our PALS group here meeting on a nice sunny day as usual in Plymouth. And we can also then ensure we have a personalised experience for our students in their sort of tutorials and in their supervision in their final year projects, and sort of tailor them into the areas that they want to go into in their careers. It's also assessment by 70% coursework, so most of the there's a good chance for students to demonstrate in their practice their chemistry, as well as just sort of recall and knowledge as well. And I think that suits a broader range of learning sort of needs. In terms of where we sit nationally, this is our sort of national student survey data. We're doing really well, like many of our courses, as you've already heard. This is all to do with basically good teaching and hard work. And so we're sort of first in the UK for the national student survey for our feedback, second for assessment and feedback in this sort of national student survey. So we're rated highly by our own students, and that really shows, I think, an anonymous sort of survey that gives some credit to that. More broadly, this is one of our national newspaper league tables, one of the sort of highly regarded ones, and our chemistry courses sort of breaks into the top tier of chemistry courses in the country. And as I mentioned, this is a lot to do with the actual teaching side of things and the environment that students work in, as well as the environment of the university as a whole. So hopefully that sort of gives you an idea of that. And we're accredited by our independent professional body, the Royal Society of Chemistry. And again, that gives you some feeling that independent people have looked at our course and given it this sort of seal of quality for both the BSc and the MChem. So in order to do that, we have to have these modern labs, and so we've got these teaching labs here on the left-hand side in the Davy building, which is on the campus that some of my colleagues have shown you already. And then we've got these instrument labs, which are research grade labs, which are also doing research. They're also doing contracts for industry, and our undergraduates are coming in as well. So it's a kind of really nice sort of blended mix of environment of real working lab that our students benefit from. And we've got a lot of technical experts who have PhDs and are working with industry and research alongside teaching our students in addition to the other staff. Okay, also the labs are ISO accredited, and that's really important in terms of what employers will see on our students sort of profiles afterwards. And ISO is the International Standardization Organization, sorry, International Organization for Standardization, and it's a management structure which many students will end up going into industry, research, and the public domain, and be expected to work to ISO certified levels. And we teach this within our labs. And again, this is something that employers want and really cherish. Just briefly, the course structure. We have one BSc course in chemistry, which takes our students through from year 1 to year 3, with the increasing sort of focus on our analytical skills, really starting in year 2 and ramping up to the research project in year 3. And then they have the option to continue that with an MChem in analytical chemistry. So a really great opportunity to be able to extend their studies into that area I've just mentioned. And just as my colleagues have mentioned, we also have a foundation entry into that, that sequence as well. So the MChem at the end is an opportunity for students who really embrace that analytical training and want to go further and work to other ISO sort of standards, such as 17025, which is sounds like just a code, but actually it's a really important laboratory standard for methods and calibration, which are used again worldwide certification. And continue to work in those ISO 9001 certified labs as well. So that whole practice starts building up. And this course was put together, you know, in discussions with analytical laboratories from sort of private ones and laboratory sort of discussions. So we've really sort of focused it in for what we want students to have to be able to be very employable in those fields. We offer placements varying from sort of blue chip companies like GlaxoSmithKline. People have worked in Imerys, which is the clay works nearby in Cornwall, but it's an international company, all the way through to AstraZeneca, which I'm sure you know is a pharmaceutical company. And so that's a really great way of sort of boosting chemists' employability and getting their foot in the door with industry too. Here's the team. So myself, my colleagues who work on this, and we're all active researchers or teaching experts, and our research focuses on environmental chemistry all the way through to industrial applied chemistry. We have projects working with EDF, BP. We have a spin-out company, Poor Expert, which Maurizio, my colleague, runs, and we work more locally with other companies such as Cornish Lithium, work with the Eden Project, and apply our analytical skills to help solve problems in all these areas. And that takes us all over the world, from the North Pole here, shown one of my colleagues, Simon Belt, was working up here, all the way through to the Southern Ocean, where I was over Christmas this year. So we really, chemists don't just sit in labs, we get around and we bring that kind of excitement of what we do into the classroom with our students, and that helps them sort of be more engaged. So that's, I think I'll leave it there. This has just been my research as well, out here in the Atlantic Ocean, again showing that we get involved in these big global issues of climate change, as well as applying our chemistry directly to industry. And so hopefully that's been of interest. I'll leave you here with just with some ideas from our graduates, and the fact that they've taken their chemistry, used it in their careers, and testimony to the course for delivering there for them. And there's more information on our website. So just to wrap up, our sort of focus is for high employability for our chemists. It's a practical hands-on course with ISO certified labs. Highly rated teaching, which I've shown you some of the stats for that. Accredited by the Royal Society of Chemistry, and a degree by approximately 70% coursework, allowing chemists to demonstrate by practice their skills, as well as via examinations. And we have the opportunity for extension to professional level training in analytical chemistry for those who wish to stay on with us. So thanks very much. There's more information on our website here, and my email address will be on the presentation if you wish to get in contact with me. And I've run just slightly over time. I apologise, John, but thank you for your attention, and hopefully be in contact with you soon.